All right, domain is asking us what the possible values of x can be. Okay, we have found domain from a graph quite a few times by now. What I want to work on is seeing if we can pick out the domain from an equation instead. So if I don't take the time to graph it, if I just look at that initial equation, can we pick out the domain? There are two things that we need to remember when we're doing the domain. In a fraction, the denominator, so the bottom of the fraction, cannot be 0. Okay, in a fraction, we can never divide by 0. If you do it on your calculator, it gives you an error. The second thing is in an even radical. So by even radical, I mean a square root, a fourth root, a sixth root. The radicand, that's the thing under the radical, has to be greater than or equal to 0. What happens if you have a negative under a square root? Yeah, it's not a real solution. You get an imaginary number. So when we're talking about graphs, we're only talking about real numbers. So these are the two things we have to worry about. If it's a fraction, the bottom of the fraction can't be 0. If it's an even radical, whatever's underneath has to be positive. Beyond that, our domain is everything. Negative infinity to infinity. Okay, so let's take a look at one. All right, so number one, do we have any fractions? No. Do I have any radicals? No. So what's my domain? What number can you plug in for x? Anything. So my domain is negative infinity to positive infinity. All right. Number two. So if I look at this one, do we have any fractions? We do have a fraction. Okay, in a fraction, what has to be true? Okay, the denominator is 2, so 2 can't be 0. Is 2 ever 0? No, so what can I plug in for x? Anything. So it's also negative infinity to infinity. All right, let's look at some more. Number 3. Oh. So, we have a fraction. In a fraction, what can't happen? So the bottom of this fraction, so x minus 3, can't equal 0. So that means x cannot be 3. All right, so x can be anything except 3. How would I write that using an interval? Two. Everything except 3 means it could be smaller, it could be bigger. It just can't be 3. Number 4. This one has a radical. Okay, it's an even radical because it's a square root. What does that mean? Look back at the very beginning. If it's an even radical, what did we say? The radicand, so greater than or equal to 0. So the thing under my square root, greater than or equal to 0. All right. So then we just add our 1 over. So x is greater than or equal to 1. I want an interval. If you need to draw yourself a picture, you certainly can. It's not required. Greater than or equal to means a bracket. Everything bigger. So how do we write that?
Bracket.
Means if you pick any number from 1 to infinity, you'll be able to get an answer on this. If I pick something smaller than 1, I'm getting imaginaries. All right. Let's look at this one. What do I do?
For 2x minus 3, greater than or equal to 0.
Good. Even radical because of a square root, so greater than or equal to 0. So 2x greater than or equal to 3. So x is greater than or equal to 3/2. So how do I write that?
Bracket 3 halves.
Number 6, it's a fraction. If we have a fraction, what can't happen? So this can't be 0. What makes that equal 0? So it can't be either. Can't have a positive 2 or a negative 1. The interval notation gets a little bit more cumbersome here. If you have multiple values, x can't be. It's everything except the negative 1 and the 2. And so what happens is it breaks it into 3 pieces. So it would be like negative infinity to negative 1, union negative 1 to 2, union 2 to infinity. Everything's smaller than negative 1, between negative 1 and 2, and bigger than 2. That gets a little bit annoying on these. If it's just one number that x can't be, so like here when it couldn't be 3, I expect this interval notation, no matter what. If you get more than one value that x can't be, you can write the interval. I will also accept it if you just tell me what x can't equal. So because this interval notation does get a little bit longer, on those questions, if it's multiple values, I will accept it if you just want to say x cannot be. However, if it's only one value x can't be, I do want you to go ahead and write the interval. I want you guys to try a couple. Number 7. We have a fraction. In a fraction, we know the denominator can't be 0. So my denominator is just 2. So 2 can't be 0. Do we have to worry about that? No. So what's my domain? All right, number 8, we have a radical. The thing under the radical is just my x. So the radicand is just a number under the radical, has to be greater than or equal to 0. So how do we write that? It's not saying not equal to, it's saying greater than 0. So it's just bracket 0 to infinity. So the fractions are the ones that are not equals. The radicals, you have an inequality. All right, let's try some more. Let's look at this one. Okay, actually, can I change this problem? I don't want to do that one. Let's do this one. Let's do radical 4 minus 3x. So we know in a radical, the radicand, the thing underneath, has to be greater than or equal to 0. I subtract my 4. What happens when you divide that negative 3? Flip the inequality, positive 4/3. To write the interval, you are always welcome to draw yourself a number line if you need to. Less than or equal to means bracket. Less than is going to the left. So what's my interval on this one? Number 10. I have a fraction. I know that in a fraction, the denominator cannot be 0. What do I need to do with that? Well, it's got an x with it. So
You have to square the whole thing, don't you?
if it were x squared minus 4, we could. What can I take out of both of those? Okay, so now it's factored. So now can you tell me what can x not be? Two things multiplied that equals 0. We did another one like it earlier. Can't be a 4. Or what would make this plain x a 0? Just a 0. So when you have things factored, you set each parenthesis equal to 0. So for those, I told you, if it's more than one value, you could leave it like that. If you wrote the interval, it's everything smaller than 0, in between 0 and 4, and bigger than 4. So I would take either. All right. Why don't you guys do number 11, and if you have time, try number 12. It's a radical, so the thing under the radical, 4x minus 9, greater than or equal to 0. Don't lose that greater than or equal to. So that means 4x is greater than or equal to 9, so x is greater than or equal to 9/4. Think about what that means. Equal to means bracket, greater than is going to the right. So my domain is bracket 9/4 to infinity. Number 12, what's different about this one? I have a fraction and a radical. So let's deal with both parts. The fraction says the denominator cannot be 0. So if you square, you just get that x can't be 0. The radical says the thing under the radical greater than or equal to 0. I have to put both of these together. Okay, I know it has to be greater than or equal to 0, but then it can't be 0. So what does that change? Yes. Greater than or equal to, so I knew it's only that half. The fact that it's not 0 means this will be a parenthesis. It's a parenthesis, 0 to infinity. So we can have both fractions and radicals in the same problem. Do a few more. Okay, number 13, again, has both a fraction and a radical, so we have to do both parts. The fraction tells you the bottom cannot be 0. So that means x cannot be -2. The radical tells me the thing under the radical, so 1 minus x, has to be greater than or equal to 0. So if I subtract my 1, negative x is greater than or equal to -1. Divide by a negative, which flips that inequality, so x is less than or equal to 1. So let's think about what this means. Less than or equal to 1 would start at 1 and be everything to the left. But I'm telling you, it can't be -2. So my interval is coming from negative infinity. I stop at -2 and it gets a parenthesis. Union starts again at -2 and goes until 1. And the 1 would get a bracket. Is that okay with everyone? You guys are saying very little today, even less than normal. Does that mean you really don't understand or you just really don't want to be here today?
Second.
I'll try not to take it personally. 14. What do you think that domain would be? I have a radical. The only thing under it is a 2. If you have a radical, the thing under the radical has to be greater than or equal to 0. Isn't 2 greater than or equal to 0? So what's my domain? Two more. Let's see if you guys can talk to me. I know, it's terrible. Terrible. So 15, do I have a radical? Okay, so I know the radicand, the thing under the radical, has to be greater than or equal to 0. So that tells me x has to be greater than or equal to 1. Alright, so I already know that much. Greater than or equal to 1 is everything larger than 1. Then I have a fraction. In a fraction, what can't happen? So x plus 3 cannot be 0. So x can't be -3. If I'm already bigger than 1, do I have to worry about the -3? No. So my domain is just 1 to infinity. All right, and the last one. So in a radical, the thing under the radical, greater than or equal to 0. So we subtract our 5. What happens when I divide by -2? So x is less than or equal to 5/2. going to the left, equal to means bracket, so how do I write that?
That's right.
All right. Are we having any issues with this? So, on Classroom, there is a domain handout. The front should be very familiar. Those are the examples we just did. So you're doing the back of it only. So it's a two-sided handout, but we did the front together, so it's the back. It should be 1 through 12.